Good morning students. Today what we are going to do is that we are going to discuss questions on electricity. Like I will take different models of question. Like mostly you will have doubt like how to find the answer for like those kind of questions we are going to see. Like let's say this question given to you here. The mass of the wire of copper is in the ratio 1 is to 3 is to 5. Length are in the ratio 5 is to 3 is to 1. The ratio of the electrical resistance is. And you know that resistance formula R is equal to rho L by A, right? Rho L by is the resistance formula, but the problem is that here is actually copper is given, copper is the wire, so copper is the wire means resistivity will be constant out. So length ratio is given, that is very good, fine, we can find out. But actually the problem is that instead of giving the ratio of area, he has given that mass ratio given, right? So how to do it? For that what we are going to do is like we need mass in our resistance formula. For that we will write R is equal to rho L. Here you actually having area multiply with length. Numerator also multiply with length. So what happens is area into length will become volume. Area into length becomes volume. Then you write R is equal to rho L. This is your rho actually. Actually rho has nothing to do. So like let's say L divided by area into length becomes volume. Right, area into length becomes volume, and volume actually you know that volume what you have to write is volume is equal to, you can write mass upon density, mass upon density. So here actually this L and L we have multiplied, so that become L square, because here we have multiplied. So this is because resistivity doesn't matter for us, it is a constant, because since that copper wire is given means that resistivity of a given material will not change. Now resistance is directly proportional to what you will write is that resistance is proportional to L square by M, right? So that now you can find out, that is the main thing. So L square, L1 square by M1, so that if you take the ratio you have to take L1 square actually is given is, first one length is given actually 5, that is L1 square, right? So 5 square divided by M1 is 1 is 2. So second length is given 3 square divided by second mass is given actually 3. Next is given to you. Third length is given 1, so 1 square, and mass is given 5. So what you get here is you are going to get like 25 is 2. Actually you get is here is 3, and here you get 1 by 5, right? But the thing is that you won't get the answer in that way, so you have to take in a simple ratio, fractional ratio is not required. So what you do here, in denominator 5 is there, so you need to multiply 5 with each term, so that you get a simple ratio. So if you multiply with 5, 25 into 5 you get 125 is 2, you get 15 is to 1, so the answer will be 4, right? So I hope you understand that how to relate. Actually the main thing is here is we have to relate that resistance and mass, but no direct formula is there. So we have taken this area, actually we made is volume, and we got volume is equal to mass by density, so we could find out, right? I hope this is clear for you, right? Maybe 1988 question, but you will see that those models are nowadays repeating old models, but important question. Next one, let us see. This second question is that based on like yesterday I have discussed with you, in the previous session we have discussed the concept here is voltmeter has infinite resistance. Voltmeter has conceptual question. voltmeter has infinite resistance. So based on that concept, this answer will be done. Now look at in first diagram. Actually, voltmeter will be connected in parallel. Fine. Some resistance 10 ohm is there here. Okay. Same 10 ohm resistance is there. And the battery supply voltage is 10 volt. Here also supply voltage is 10 volt. That is not a problem. Only problem is that in the first condition you actually are connecting no resistance in series. In second one you are connecting resistance in series connection for this voltmeter, right? So what actually concept is, yesterday I told, whatever resistance you connected in series, actually it is an ideal voltmeter having infinite resistance. So with infinite resistance, anything you connect makes more difference, right? So what will happen here? Nothing is going to change. So actually here you can say, sir, because your V1 and V2 will be equal, it will not change, because you are connecting in series connection, you are connecting a resistance in series with voltmeter. Don't change anything over here, because voltmeter has infinite resistance and you get I1 is equal to I2. So this is concept, this comes under conceptual question. Actually you will not never be taught in the class and all that. This is like a conceptual question, like which this is the thing you should know. Voltmeter has infinite resistance. So sometimes they ask conceptual questions, and conceptual question will be very easy, but you have to apply that concept. That is challenge. Okay, next one is this one. This is also having concept is there in this also. So here given 2019 question, Neet 2019 question. Given that 6 identical bulbs are there, so you have been given 6. Okay, similar bulbs are connected as shown in the figure, and you are having some DC source, supply voltage is your DC, right? And identical bulb in the sense all having same resistance, right? And zero internal resistance of the bulb, that is very good thing. Now the ratio of power consumption by the bulb when all are glowing means everything is working in this, right? So I actually would have now the challenge with you is that, sir, I have to use P is equal to I square R, that formula. Sir, I have to use P is equal to V square by R, otherwise I have to use P is equal to V into I. That is only problem. Problem is that you don't know exactly which formulas is suitable. So that if you don't use, you will struggle. You will struggle so much. Power questions are like that. If you are catching the correct thing, you will get answer within short time. But if you are not able to catch, how much time also you spend, you will not get the answer correctly. If you get also, it takes a lot of time. Okay, so the thing is that in both the situation number 1 and situation number 2, the supply voltage remains the same. That is important, because current will change with resistance. So but voltage, how many bulbs are glowing, irrespective of that, voltage remains same. So we will go with second form, P is equal to V square by R, because their voltage remains same. So power will be inversely proportional to resistance. It says supply voltage remains same, power is inversely proportional to resistance. Now all are glowing in that. If all are glowing, that is power in first situation and power in second situation is equal to resistance in second situation by resistance in first situation, because here voltage remains same, power is inversely proportional to resistance, right? So in the first condition all are glowing means all having same resistance, R and R. But remember, first thing you should find out effective resistance means, because your wire is connected, you cannot say, sir, this and this are in series. Yeah, this is in series, but in between wire is connected, now they are no more in series. First this 3 you will take in parallel connection, these 3 are in parallel connection, so this becomes R in parallel connection means you get R by 3 and this is R by 3. So in the first condition, actually first side R by 3 and again another size is R by 3. So R by 3 and R by 3 in series connection, because this will give you R by 3. First you should find out this 3 and then you have to find out this 3 and then in series, right? So you get 2R by 3. In first condition resistance, right? Second condition resistance, actually given that in the section when 2 from A and 1 from B is growing. 2 from A means actually 2 means actually you get R by 2, and 1 from here second part R. So R plus R by 2 is equal to 3R by 2. So actually easily you can find out R2 is your 3R by 2 divided by 2R by 3. So you get here 9 by 4. So this is also concept is only one concept is there. What is there means voltage is same means we have to apply V square by R. So power is inversely proportional to resistance, right? So this is the second one. Next move on to the third question. Third question is actually little standard in the sense because here you need to actually understand about power little, right? So whenever this is given your what you see, this is called rating of the bulb. Whenever rating of the bulb is given, the first thing we have to do is resistance of the bulb we should find out. And for resistance of the bulb you use V square by P. So voltage actually is given 100 and this is rating of the bulb. Actually this from rating we are finding. Rating is what bulb rating is given. From rating we are finding out resistance of the bulb V square by P. V square means 100 into 100 and this is actually 500, right? Power. So from here you get 20 ohm is the resistance of the bulb. Fine. 20 ohm is the resistance of the bulb. Now what we have to do is that it works perfectly because the supply voltage is 100 volt. So when you supply 100 volt to the bulb and you don't connect anything with the bulb, okay, so that time like if you have a bulb, only one bulb should be there and you supply 100 volt battery, then it will glow. Other than that it will not glow because supply voltage should be there with 100 volt. You say sir, no, I am using 100 volt battery, but you are using 100 volt battery but you are not connecting only one bulb. You are connecting more than that, so voltage get divided. That is why what happens mostly, whatever the voltage supply is required, he may not get, so that this power gets fluctuated. Now in this condition what is given, 230 is our supply voltage we have. So we have 230 supply voltage, right? And in that you have connected a bulb. Now need to connect something in series connection. And this supply voltage, that bulb having the resistance of 20 ohm, we calculated. Something else should be connected in series. Okay, so that it will actually glow with the brightness of 500 watt, right? So here what actually you will do is that here this is supply voltage 230, right? So in this condition what you are actually going to do is that you use the formula of, now which formula of power you will use because you have connected two resistance in series. So better you go for this formula, P is equal to I square R. When series connection there we use this. Power across the bulb is we have to find out. So power across the bulb is 500 and current you can find out total supply voltage divided by total resistance, that actually you get here is Rs plus 20 the whole square into this power of the bulb you are finding. So you have to take resistance of the bulb, that is 20. Okay, so this 20, 500 by 20 if you take you get 25 and the square becomes square root here. So you get 230 divided by Rs plus 20, right? Now here 5 you will get this 5 and 5 into Rs plus 20 is equal to 230. So right, so if you are going to divide this, what you get 46. Here if you divide you get 46 minus 20 you get 26 ohm resistance. The main thing is this formation of this equation. When you are able to form this equation you will get. Some people start 230 into 230, all that nonsense, no need. Square will go that side, becomes square root, things will become simple, right? So this is the question again from power. Next question, see here concept I will tell you like how to find out. Like calculation part you can actually do it. Here actually you know that resistance in series connection, you know, resistance in series connection you write like R is equal to, you write R1 plus R2, right? R is equal to R1 plus R2 you write. Now here actually resistance not asking, here is asking actually what is that conductivity. So conductivity and resistance relation you have to know. So actually you will write R is equal to, you know, is rho L by A. So resistivity formula you will be knowing R A divided by L. From here conductivity is L by R A. Okay. So L by R A is the conductivity, right? It means from here if you have to write resistance in terms of conductivity they have given here, right? In terms of conductivity you have to write resistance means in terms of conductivity we have resistance formula. Now you write actually two wires are there connected, right? Two metal wires of identical dimensions are connected in series connection. So they actually are connected in series. Identical dimension means what happens, their lengths are equal, area of cross section is equal, right? So here two, and this is actually here write effective resistance means write R formula in terms of conductivity you will get is L divided by sigma into. Now this is total resistance. So total length you will take. Total length will become L1 plus L2. Okay, here effective conductivity. Area of cross section will not be affected because then R1 is equal to, you will write L1 sigma 1A plus L2 sigma 2 into A being equal, it will get cancelled and length is also equal. You substitute here this sigma effective, finally you get is 2 sigma 1 sigma 2 divided by sigma 1 plus sigma 2. Thing is that same formula you have to use, R is equal to R1 plus R2, only that resistance would be in terms of conductivity, right? So R equal to L by rho A, if you do, you can find out the answer. And this is a question which confuses, actually looks very simple. Many of you will say, sir, VB equal to VC. Quickly by seeing the answer, the question itself, they said, sir, it is in parallel connection. So VB equal to VC. That is actually perfect. VB and VC will be equal, no problem. But there are two options. So like most of the students, if you go like this one, you will say that's this A is in series connection, but B and C are in parallel connection, and you will mark the answer. But that is not correct answer. Actually, what is the voltage across B or C? So we know that VB equal to VC, no doubt. But what is that voltage across them? Can it comparable to A or not? That we should check. So first let us say current is I. So total current is I, then we can say that voltage across A is equal to, we write current into resistance of A, IR. Now here actually you should find out this total voltage, means what you should do is, you have to find out effective resistance of B and C. So R effective for B and C. So R effective if you get here, what you get actually 1.5 and 3R is there. So you take 1.5R, R1, R2 divided by R1 plus R2. And that is equal to R. Okay. Then you write voltage across B or voltage across C is equal to total current, and what is their effective resistance R. So that third option will be correct in this condition. I hope it is clear for you. Next one, let us see. This kind of question, actually your material and all that will be given very complicated method and all that, but here what we are going to do, we are going to take very simple method, simple easy method, because here is saying that 12 centimeter wire is given. So 12 centimeter wire is given, so definitely made up of the same material, right? Because here just given 12 centimeter of wire. Okay, AB's and the length of the wire is different. Okay, resistance is asking. So actually you write R is equal to rho L by A. So resistivity is same, area also will be same. Resistance only depends on length, right? But he is saying between two ends, between AB, ABC and CA. So resistance is proportional to length. So between AB I have to find out, means this is the point between AB. Then between AB, BC and CA. So AB means this length. So BC now becomes this two in series connection becomes. So you can think resistance directly proportional to length, means you can say sir 5 ohm, this is 4 ohm and this is 3 ohm. So resistance actually is given. Now between this AB you have to find out, means this two becomes in series connection. So resistance across AB is equal to 5 plus 4, 9. So you get R1, R2, 27 divided by 13. Likewise for BC you should find out, means 5 plus 3, 8, 8 into 4. 8 into 4 like you write 32 by 12. Sorry. For BC, let me check. And actually for AB we are writing 5 plus 4, 9. 9 and 3 are in parallel connection. So here it is 12, not 30. Because this 5 plus 4 is 9 and 9 and 3 are in parallel connection, means 9 into 3 divided by R1 R2 divided by 1 plus R1 plus R2. So this is 27 by 12, this is you get 32 by 12 between BC. BC means this 5 plus 3, 8. 8 4 is 32 by 12. Now CA is left out. Then this becomes in series 3 and 4. So get 7, 7 5 are 35, because actually CA means from where to here, here to here, 4 plus 3, 7, right? So 7, 5 are 35, R1, R2 divided by 7 plus 5, 12. So here no calculation should be done, no simplification should be done. At last directly if you take the ratio between them, so if you take AB, BC and CA, denominator is common, it will be cancelled, and the final answer left out is 27 is to 32 is to 35. What you have to learn here is that don't do cancellation and consider length and resistance relation directly consider. You will get the answer, because here area of cross section is equal and they are made up of same material, right? Next, this question is again like a little complex for some strains and material explanation also is complex. I will tell you the simple method for this. What is that? A ring is made up of a wire having total resistance of the wire is 12 ohm. Let us say this part, length part L1 having resistance R1, this part having resistance R2, right? So actually because before it was this total ring is made up of a material of wire having 12 ohm, means any of this plus this gives you 12 ohm total resistance. So first you write R1 plus R2 is equal to 10 ohm. Next. Now when they are connected like this two terminal came, then effective resistance become 8 by 3. It means they become parallel now. So R1 R2, sorry, this is this you get R1 R2. So here you get actually effective resistance parallel connection R1 R2 divided by R1 plus R2 is equal to 8 by 3. Right. Now from here actually you can actually get R1 R2, because R1 plus R2 is given to you 10 and actually it is 12. Okay, 12, so this is given R1 R2 divided by R1 plus R2 is equal to 12 is given. So from there what you can find out, R1 R2 you can find out, because 12 into 8 by 3 gives 32. 32 ohm. Now you have to solve in order to get R1 and R2. So R1 plus R2 is 12. R1 into R2 is 32. So clearly, if you mathematically, if you think also, R1 should be 4 ohm and R2 should be 8 ohm. The reason is very simple, because here bigger length will have bigger resistance. So if you take the, actually if you want to find out the answer, the sum of those two numbers should be 12. Sum of those, multiplication of those two numbers are 32. So it means you get 4 and 8 combination. This R1 is small because length is small, and R2 is big, that is you get 8 ohm, right? What did we get here? 8. Now he is asking ratio of conductors should be connected, length ratio, and you know that I told you clearly R1 by R2 is equal to L1 by L2. So resistance for first one is 4, second one is 8. So 4 by 8, 1 is to 2. This is how you are going to do it. I hope it is clear, because this question will be little standard there. Okay, so like I told you in simple method, first I have told you total resistance R1 plus R2, that is given as 12. And when it is connected in parallel connection, actually it becoming 8 by 3. So I have written parallel connection formula, R1 R2 by R1 plus R2. From there I made two equation, R1 R2 is 32 and R1 plus R2 is 12. So by like trial method, if you use 4 and 2 instead of solving 4 and 2, smaller resistance will have a smaller length, will have smaller resistance. So 4 we are giving for R1, 8 we are giving for R2. Now here in this question, actually you have problem is that actually in this kind of question you need to find out first total resistance of the wire. Total resistance. This is not given total resistance. It is given resistance per unit length, 12 ohm per meter. 12 ohm per meter is given, means you have to find out total resistance, means total length into resistance per unit length. Okay, total resistance, total length is given. How much you have your total resistance here is, total resistance is given, actually total length is 2 pi r. Radius is given as 10 centimeters, so 10 by 1, sorry 10 by 100, 1 by 10, and resistance per unit length is given 12. So if you do this, you get 2.45 ohm. So total resistance is 2.4 pi ohm. So this is half of length, means this side you get half of the resistance, 1.2 pi, and another one you get is 1.2 pi you get here. Here also this second part also you get 1.2 pi. And you know that when we are coming in parallel, the effective resistance you get R effective is equal to R by 2, that is 1.2 divided by 2, you get 0.6 pi ohm. Okay, so this question actually will be confusion for many of the students, right? So you'll see that in simple method how you are going to find the answer, right? It's saying in the circuit shown the current through the 4 ohm resistor is given 1 ampere, and this is where your 4 ohm resistor is there, right? And here current is actually 1 ampere. So 1 ampere of current is going, then actually the voltage difference between, you can find out voltage difference across this 4 ohm resistor, right? And this 4 ohm resistor, actually voltage difference will be 4 volt, right? But remember here to here voltage is 4 volt, here to here voltage is 4 volt, means here to here also 4 volt. The reason is that nothing is connected from in between, here 4 volt is there, means total voltage from here to here is 4 volt, right? The reason is that nothing is connected, so total voltage actually is 4 volt. Okay, total voltage is 4 volt from this point to this point, Total is 4 volt. Right. So current is 1 ampere here. Voltage is actually 4 volt from this point to this point. Now you can find out the current here on this. Actually, total voltage between this point to this point is 4 volt. And if you can find out the total current here. And to find out total current, actually you use the formula I is equal to V by R. So potential difference from this point to this point you have learned is 4. Resistance actually 0.5, 0.5, because you are trying to know the total current in this point, because he is interested to find out potential difference between M and N, right? So from here to here you have to find out, means first of all you have to know what is the current here in this line. So current into resistance between M and N only 1 ohm, right? So current is equal to the voltage is 4 divided by resistance you get is 0.5, 0.5 in parallel connection, you get 0.25 plus 1. So what you get here is 1.25, right? So 1.25 you get here. Then he is asking the potential difference between point M and N, he is asking, right? So first we will get total current 4 divided by 1.25. So what you actually can do, 400 by 125, 25 5 is a, and it is actually 16 times, and you get 3.2 ampere. Current is 3.2 ampere. The voltage across M and N, current, whatever current we got, 3.2 into resistance is 1, so you get 3.2. Okay, so like directly we can find out from between point M and N, current, whatever current is there, that is 1 ampere. Okay, and sorry, current is 3.2 ampere, the resistance between M and N is only 1, right? So actually we can find out from this, and we can get the answer 3.2 volt, right? Let's see the next question. This is very important model, very important question actually, because here you get confused how to find the answer. So that's why it's like important question. Here given that power across 8 ohm resistor, power across this is given, power across it, right? Is given you 2 watt. Here power across 8 ohm is given 2 watt, and he is asking what is the power actually across this. So what to do actually and how to do. So here in this condition you see 8 ohm resistance is there, power is given. So power formula 2 are there. So 2 power formula is there, you know that P is equal to, you can write as I square R. Otherwise you can write P is equal to V square by R. But which will be more better for us to use is, if you use P equal to V square by R, we can find out potential difference between this point to this point, right? So here to here you can find out potential difference, and that is better for us. So power is actually given 2 watt. So voltage across this 8 ohm we can find out. So V square, and here it is given 8. Because power is equal to V square by R. So voltage potential difference for this is, we don't know, resistance is 8. So that voltage you get is 4 volt. So you are getting 4 volt. So like previous question, actually from here to here you got 4 volt, right? 4 volt you get. Now like previous question you can find out current in this line, and that current formula I is equal to, that potential difference is getting is 4, I equal to V by R, 4 by 4. So you get 1 ampere of current. Right, now he is asking what is the power across this 3 ohm resistor. Power across 3 ohm resistor, you can write P is equal to whatever current is going in 3 ohm resistor, that is, we can use formula I square into R. Current is actually, here you have only 1 ampere, 1 square into 3. So you get as 3 watt, right? In very simple way we can find out by using this correct formula. Okay, so we are using P is equal to V square by R, so that we are able to find out potential difference between this point to this point, right? Then we can find out that the current in the upper branch, we got what is the current in the upper branch. Then we can find out power in 3 ohm resistor. Next, current in the given circuit, like this is simple. And actually, I was thinking to tell you how. So I'll teach you that current you can find out. Division of current also I'll teach you. One extra thing I'll teach you, because current finding is not a great thing here. You can find out current is actually I is equal to total voltage is 4.8. Total resistance actually 6 and 6 are in series connection. So 6 and 6 are in series connection, means 3 makes, and this 3 and that 3 in parallel connection. So actually R effective you can find out is 6 and 6 in series connection means 12, and this, sorry, this is, yeah, series connection 12, and here 3, 12 and 3 are in parallel connection. So 12 into 3 effective R1 R2 by R1 plus R2. So you get here 6 and 6 12, 12 3 is 36 by 15. This is 3 12 by 2.4 ohm effective. Right. So here total current is equal to total voltage by total resistance 2.4, 2 ampere. Fine, but I'll not stop here. I'll ask you, like, let's discuss the current here. Current division, let's say this side is I1, this side is I2, because other question is there in that they ask the current actually in different branch. Then I1 is equal to resistance of actually you'll have the formula I1 is equal to R2 divided by R1 plus R2 into total current. So here I1 you can write as R2 means the resistance of second branch, that is 12, divided by total resistance, that is 12 plus 6, into total current whatever you got 2, right? You'll get 12 by 18 into 2, so you get 4 by 3 ampere, and you already know 4 by 3 ampere is I1 will be more because the resistance is less. Ultimately you can find out I2, and that I2 is equal to total current minus current this side. So total current was 2 minus 4 by 3. So you get 2 by 3 ampere. So finally we are getting 2 by 3 ampere. This is the I1 and I2, right? So let us move to the next one. Yeah. Now current through 3 ohm resistor is given to you. Okay, current through 3 ohm resistor is given as 0.8 ampere, and then he is asking potential through 4 ohm resistor. Same kind of like little model of previous question, only what we are discussing like that. Actually again you have been given here current, right? Current is given as how much? 0.8 ampere. Then actually voltage you can find out. So voltage across 0.3 is 0.3, sorry, this 3 and 8. You get 8 3 are 24. So voltage you get 2.4 volt. Now he is asking potential drop across it. So how do you find out potential drop actually? Because you know that there is resistance 4 and here it is 2.4, right? So there are many methods are there. One method, like, you can find out total current. Total current is equal to total voltage by total resistance, means of this two total resistance. Total resistance of 6 and 3 in parallel connection, if you have to find out, in parallel connection if you have to find out for this, you will write in parallel connection R1 R2 divided by R1 plus R2, so you will get 2. Okay, so actually we are getting total current Actually, sorry, total voltage across it was 2.4, and total resistance is actually 6 and 3. Total resistance is 2 ohm. So you actually get total current is 1.2 ampere. Okay, so that total current is, we have 1.2 ampere. Then potential difference formula, you know that V equal to IR. So current we have got is 1.2, resistance 4, so you get here 8.4, right? So this is also simple approach. We have to find out in this way so that you can get easily answer. Now, actually, I was discussing previously about that. What you say? I have told you this potential terminal voltage, potential difference, and what is say EMF kind of concept is important. So, in this is given that 2 ampere is current flows through 2 ohm resistor. Actually, you should know the diagram first of all. So, diagram will be like this. You have 2 ohm resistor, and actually that 2 ohm resistor is connected through a battery of EMF E. Internal resistance you don't know. Current is also given to you, right? 2 ampere. So first you will write two equation you will get. First you will write current equation. I is equal to, in this, when internal resistance is given, E divided by small r by capital R. So current is equal to 2, EMF we don't know of the battery, and total resistance is 2 plus 2 plus small r, right? Because external resistance is given to you 2, external resistance is given to you 2, but internal resistance you don't know. Total resistance R plus capital R, equation number 1. Likewise, equation number 2, 0.5 ampere of the current, E divided by small r plus here also capital R. So in the first equation, like capital R is R1, here let us say R. Okay, R1, R2 we know 2 ohm and 9 ohm. So if you write the equation, if you write 2 is equal to E divided by small r plus R1 is given to you 2 ohm. So, and second equation if you write, that is 0.5 is equal to E divided by R plus 9. Right, so when you divide this, E will get cancelled and you can find out the answer by dividing. You will get the answer according to me 0.5 ampere after solving. It's nothing, one step you have to just solve that by dividing. E will get cancelled, right? Next, this is 2023 also. The same model question has appeared for 2023. Okay, now here he is asking that a current and potential difference between the point P and Q. So good question in P and Q. First of all, you have to find out the current. Current is equal to effective voltage. Effective voltage here you see this two batteries are there. One is 4 volt, one is 8 volt. But they are not connected rightly. They are wrongly connected. Wrongly connected because positive and positive is connected together. Wrongly connected, you get effective EMF not to be added, to be subtracted. So effective EMF is 4, and total resistance you will see 2 plus 1, 3, 3 plus 9, 12. Total, because all the resistance are in series connection, we get 1 by 3 ampere. Potential difference between P and Q you have to find out. So you can apply Kirchhoff's law from P to Q, but not needed. Directly you know that both P and Q, and here they are in parallel, they will have same voltage. So you can go to the second part, this one, to find out potential difference. V is equal to actually I into R, because this is not in parallel connection. Same current will pass. Same current will pass and current direction will be this, because this is 4 volt, this is 8 volt. So 8 volt will decide the current. So voltage across is I, we got 1 by 3, resistance is 9. So you get 3 volt, right? The answer will be 3 volt and current is 1 by 3 ampere. Next, this is the wire of certain material stays slowly by 10% new resistance, specific resistance. Specific resistance also resistivity. Know that specific, that resistivity only will change by heating the material or by changing the material. So material is not change means you don't expect that specific resistance will change, but actually it can change because of what you say, because of heating, some kind of effect of temperature will be there. So, but other than that, no, you cannot do anything. So, your specific resistance and new resistance, right? So, I told that if it is stressed, then you can use the formula R1 by R2 is equal to L1 by L2 the whole square. Now, here you have been given 10% it has stressed. So, R1 by R2. So, whatever length was there, 10% of that has been increased. So, actually, you can write this is L1 is L, this is L2. Square of that you can write. And finally R1 was R, R2 we don't know. L1 was L. 2L if you get 11 by 10 the whole square. So you get 121, 100. Okay, as I am doing directly. So okay, for your understanding, let us do a step. Here first resistance is R. Second we don't know. First length is L square. Second is actually 11 L by 10 the whole. Okay, because then you will get finally L square will get cancelled and all that. So you get here R by R2 is equal to L square divided by 121 L square, 121 L square into 100. So L square will get cancelled. The new resistance you get 1.21 times of old resistance. 1.21 times means it has increased. It was R, it has increased to 1.21 times of R. So the increase is 0.21. In percentage means, okay, that percentage not given, 0.21 actually increases there. Okay, and percentage means 21%. So there is a shortcut method, directly multiply with 100, you can find out. Here resistance became 1.21 times and resistivity does not change by stretching the wire, it remains the same. Okay, so this is how we have solved few questions, important questions we have seen. Okay.